Let's look at an example of a separable differential equation. Okay, so this is the example, of course, that we're looking at. dy by dx is equal to e to the power y plus x. It is a differential equation and it is separable. You don't believe me? Well, all you have to do is write it in proper form. Remember, on the right hand side we have a power with a sum in the exponent. That means that I can rewrite that at the right hand side as a product, e to the y times e to the x. And now you can see that I have my derivative being a product of a function of x and a function of y. So what I'm going to do next is I'm going to separate the variables, bring all the y stuff on one side, all the x stuff on the other side. So it'll give me e to the minus y dy equals e to the x dx. And now next step, I'm going to integrate both sides, and so that gives me on the left hand side integral of e to the minus y dy, on the right hand side integral of e to the x dx. Well, both of these integrals are very easy to compute, and probably you've already done so, and so I end up with, on the left hand side, with minus e to the minus y, and on the right hand side with e to the x, and then of course we have to add the plus c. Let's not forget to do that. So now this is already a solution. This is the implicit solution of our ODE. In some situations we may want to stop here, or if all that the question or the problem requires is just getting a solution, this may be good enough. Okay. However, let's see how do we get the explicit solution. Okay, so can we write this thing explicitly? Remember, what that means is just solving that equation for y. Okay, so let's do that. So all we need to do, of course, is first of all eliminate the negative. That gives us e to the minus y equals c minus e to the x. What's c? Oh yes, that's c. Okay, we eliminated the negative by multiplying left and right hand side by a minus 1. And yet I left that c as c. I didn't change it to minus c. Well, that can be done if you want to, but remember, it's not necessary because c is an arbitrary constant. It can be whatever value you want it to be. So if we change c to minus c, we're not really changing much at all, are we? Except putting an extra negative in there, which might complicate our writing. So in this kind of situation, we don't need to worry about changing the negative in front of the c also. However, go easy and go careful on this kind of waving of hands and doing strange things to c. Make sure that in each case, if you are in fact neglecting to put negatives or whatever other kind of things you're doing to c, that there is a good reason for doing it and not just being sloppy. Okay? So now that you have done that, we can apply the logarithm on both sides. That gets rid of the exponential on the left hand side and leaves a ln of c minus e to the x. By the way, remember, you're taking ln of both sides, not of each piece of both sides. So on the right hand side, you don't want to write it as ln c minus ln of e to the x. It has to be ln of bracket the whole thing. Okay. And now we're almost done. All we have to do is eliminate again the negative, so that gives us that y is equal to minus ln of c minus e to the x. Okay, so this is the explicit solution. We managed to get y explicitly as a function of x, and that's what we wanted to do. By the way, look where the c went. Notice that when we do simple integration, just anti-differentiation, the c is always an afterthought that we can put at the end after we've done everything else. Here we have to put that plus c into play somewhere in the middle of the process, and we have to carry it along because it could end up anywhere. Notice again, this one ends up as a term inside a logarithm, which is then has a negative in front of it, and so on. So this kind of strange locations for the plus c is going to occur fairly frequently, and so you need to take care of that c. Don't forget to put it in when it shows up, and then keep track of it all along.